What does the 36 a squared b to the third c turn into? So 36 would be 2 times 18, but 18 is 2 times 9, but 9 is 3 times 3. So it's 2 times 2 times 3 times 3. Or, if you can't do it in your head, then do 36. We have a 2 there, so that's 18. Another 2 gives me a 9, so that's 3 and 3. So 36 splits into 2 times 2 times 3 times 3. So it becomes 2 times 2 times 3 times 3 times a times a times b times b times b times c. That's 36 a squared b to the third c factored completely. 27 turns into what? 3 times 3 times 3, good, times a times b, and that's it. And 9 will turn into what? Good. The hard part is always the numbers, so take care on those, and you should be okay with the rest. Now what do? Find the matches in all three. So starting with the top one, 2. Do I have a 2? Nope. 2. Nope. 3? Yes. There's one there, there, and there. How about this 3? Yes. Here, here, here. How about A? Yep. There, there, there. How about A again? No, because even though we have one here, there isn't one here that hasn't already been circled, so we can't circle that A. How about B? Yes. How about that B? No, because right here we don't have another B, so we're done. We don't got to go on. How about that B? Nope, again for the same reason. How about C? There is no C here at all, so even though I have a C here, it doesn't count. Can't circle that one. So that means my GCF for these three monomials is what? 9AB. And you're done. So for now, you're welcome to continue doing that. Try to see the patterns that go on here. Once you start seeing patterns, you'll be able to find a GCF without having to do all that work. You can actually get to the point where you can do that problem in your head if you start to see the pattern. And human beings are built to see patterns, and you are all human beings. So therefore, you should be able to see the patterns. All right, so we're switching it up a little bit. Instead of just terms listed with commas, now we're given polynomials and we want to find the GCF. So it's the same process. Split them all up, factor them all completely like we've been doing, and figure out what the GCF is. So what does 5x to the third turn into? So 5 times x times x times x. Good. And what does 25x squared turn into? Okay. And what does 45x turn into? Okay, you're right to say 5 times 9, but then remember 9 is not prime. So it's 5 times 3 times 3 times x. Okay, so that's those three terms written, factored completely. So now we circle our pairs, or our matches, I should say, because they're not pairs anymore if there's three of them. 5s for sure, x for sure, and that's it. So therefore the GCF in that polynomial is 5x. There's your answer. That is a polynomial, by the way. Those are terms that are separated by addition or subtraction. There's three terms there, so that would be called a trinomial. So the GCF for that trinomial is 5x. Go ahead and see if you can do the second one. So what are we doing on that first one? Oh, let me change colors. So 3 times x times itself 4 times. Okay, what about that next one? No. No. What? Yeah, you got to remember the first thing that we do when we're dealing with a negative number is we divide out that negative 1. So this is actually going to be negative 1 times 3 times 3 times x times x. That negative 1 is there. You have to split it out. Okay? How about that negative 12x? What does that turn into then? Good. And like I said, the order that you write those numbers doesn't matter, but I always split that negative 1 out of there first, and then go from there. Okay, what happens now? Check for matches. So I'm starting with the top one, and I'm looking for a 3 in each one of those. Do I have a 3 in each one? Yes. Okay, do I have an x in each one? Yes. Do I have another x in each one? No. And that's all I got the rest of the way. So therefore, I'm done. And my GCF here is 3x. What does GCF stand for? Greatest common factor. Okay, so everything that we've done so far, up through problem 20 on the homework assignment, you are now able to do. So I'll give you a few minutes. That's another 6 problems that you have to do now. So once you find the GCF for your polynomial that you're looking at, you can factor it out of the polynomial. And so all of the stuff that we've been doing so far in this section has led up to the ability to do this. This is what you really need to know from this section. If you factor it out of the polynomial, then you can write what's left over in parentheses behind it. And the result is going to look like a distributive property problem. What you've done is you've undone a distributive property problem. You've undone multiplication. And what is undoing multiplication? Division, yeah. So basically you've kind of divided out that GCF, and that's the answer. And that's all factoring is undoing multiplication. You're undoing the distributive property. So if you think of it that way, that should help you when you're asked to factor something. So it says factor by finding the GCF. So I want to find the greatest common factor of these 3 terms, pull it out, and then write in parentheses what's left over. This is where I'm telling you that as you have more practice, you will get to the point where you can do this in your head. You're going to do it so much that you should be able to, and you will be able to, do these problems in your head. But for now, probably we can't do that. So let's go ahead and write these out in completely factored form so that we can circle pairs and move on, okay? So what does 4x to the 5th turn into? Good. And what does negative 24x to the 3rd turn into? Negative 1 for sure, and then times 2, that leaves me with 12. So then times 2, that leaves me with 6. So then 2 times 3. That's how you can kind of do that in your head. Times x, times x, times x. And then 8x turns into what? Good. All right, so these are now factored completely, but that's not what this is asking me to do. This is asking me to factor the polynomial by finding the GCF. So I need to circle pairs or circle matches here. So I'm going to start here. Do I have a match for my 2's? Yes. Here, here, here. Do I have a match for that 2? 2, 2, 2. So yes, I do. And do I have a match for that x? Yes. There, there, and there. Do I have a match for that x? No. And then that's just x the rest of the way. So I found all of my matches, which makes my GCF what? 4x. Now that's normally, in the past, those last problems that we're working on, that's where we would stop. But we're not going to stop here. This says factor by finding the GCF. Well, we found the GCF. Now, in my little words up here, I said you can write what's left over in the parentheses behind it. So now I'm going to put parentheses here, and I'm going to say 4x times what's left over from each term. So you can think of it like this. If I factor a 4x out of 4x to the 5th, what am I left with? Well, if you look up here, what was left over after I factored out the 4x that I circled? X to the 4th. These 4 guys right here make x to the 4th. That's what's left over from that first term. what's left over from my second term? Well, I got that -1 sitting there. I got that 2 times 3 sitting there. And I got that x times x sitting there. So what is that? -6x to the second. That's right. So I'm going to write minus 6x squared. And then what's left over out of my last term is just this 2 sitting here. So I'm going to write plus 2. And then I close my parentheses. And I've just factored that polynomial. Okay? Now, just to show you what happens, if I distribute that back in, and that's kind of where we started this section off, was distributing, multiplying polynomials together. If I take that and I multiply it together, let me pick my favorite raspberry color here. I go 4x times x to the fourth, which is 4x to the fifth. I go 4x times -6x squared, which is -24 x to the third. And then 4x times +2, which is +8x. And that is exactly what I started with up there. So I've accounted for everything. And I'm actually coming up with a problem that looks like a distributive property problem, but I don't have to actually distribute it because I went the other way. I've undone the distributive property, which means I've factored for the first time. All right, see if you can talk me through this one. What should we do? First, factor all the terms completely. All right, so what does 9x to the 6th look like? 3 times 3 times. Good thing I didn't make it x to the 28th. 5 times 3 or 3 times 5. Okay? Good. And that's it, right? Circle all the matches to make the GCF. So 3's for sure. There's no other 3, so then x works. X works again. And that's it. So that makes the GCF 3x squared. And then I open up parentheses. And what do I do next? Right, what's left over? Yeah. So that first term, what's left over? 3x to the fourth plus 5x squared plus 4. So there's your answer. Now it's factored. All right. There's a difference between factoring by finding the GCF, which is what we're doing right now, and factoring completely. Factoring completely looks like this. Just factoring, looks like this. And that's where our answers are mostly going to be, okay? If you see factored completely, then this is what they're asking you to do. But in all other cases, if you see the word factor, this is what it's asking you to do. So make sure you're aware of that difference. Okay, last problem. A helicopter landing pad, also known as a helipad, is sometimes marked with a circle inside of a square so that the helicopter pilot can see it from the air. Because when you're in the air, lots of things look very similar. So they try to find some sort of pattern that the pilots can spot so that they can find the landing place a little bit easier. What is the area of the shaded region of the helipad? Write your answer in factored form. So let's talk about how to find the area of the shaded region. So we're talking about this helipad right here. This is where the helicopter wants to land. And we're supposed to find out the area of the shaded region. So that's like these little spots right here. Well, how in the heck am I going to do that? Pi is involved somehow, maybe. You guys are given problems like this all the time, and you've been given problems like this since you first started learning about geometric shapes back in maybe the 7th grade. Maybe even earlier than that, okay? Let me give you a little problem that's simpler than this one. I have a rectangle. And then inside that rectangle, I cut out a hole. And I want to find out how much area is left after I cut out that hole. What do I have to do? Go ahead, Ben. Find the area of the hole and the area of the rectangle, and what am I supposed to do with them? That's right, because I had all of that, so it would be the area of the rectangle. And am I going to go the area of the hole minus the area of the rectangle, the area of the rectangle minus the area of the hole? Rectangle minus the circle. So area, so minus area of hole. Okay? That would give me the leftover area here after I cut out that hole. So that was a simpler version of what's going on in this problem. Do you see what you're supposed to do now? What are you supposed to do? Good. This is going to be area of a square. And then what? What am I supposed to do, though? I have the area of the square now. Subtract the area of the circle. And that will leave me with this leftover shaded region right here. Okay? So that's the concept on how to solve this problem. It's important to understand the concept of how to solve the problem before you just try to dive in and solve the problem, because then you'll never get anywhere. All right? Have an objective in mind before you start. It's kind of like you got into your car and started driving. Where'd you go? Well, I don't know. Well, why'd you go? I don't know. But if you got into your car and started driving to Basin, where'd you wind up? Basin. Right? Usually. You do things with a purpose in mind. So have a purpose before you start the problem. Now, that means I need to figure out the area of the square. How do I find the area of a square? Length times width, base times height. That's right. Well, the only dimension they give me is that one. But all four sides are the same. So the area of the square is going to be 2x times 2x, or just 2x squared outside, right? That gives me the area of the square. Now I'm going to subtract what? The area of the circle, yeah. So how do I find the area of a circle? Good. The area of a circle is pi r squared. What's r mean? The radius. What is the radius here? Yeah, they gave you it. It's x. So the area of the circle is going to be, we're just going to use the symbol pi. Pi times r, which is x squared. Now, what's that? The radius is squared, yeah. The pi is not squared, but the radius is squared. So, we have no purpose for a calculator here. We can do this in our head. What's 2x times 2x? 4x squared minus, what's pi times x being squared? Pi x squared. Now they said write the answer in factored form. This is not factored form. We should wind up with a problem that looks like a distributive property problem. So what we need to do here is find the, what? We need to find the GCF. So to do that, we need to turn 4x squared into 2 times 2 times x, and we need to turn minus pi x squared into -1 times pi, the symbol pi, times x times x. So then we circle our matches. X and x, x and x. And you're right, our GCF is x squared. So I write my GCF, and then I open up parentheses, and I write what's left over. What's left over from the first term? 4. What's left over from the second term? Minus pi. Close your parentheses and you're done. 4 minus pi. Now, we like to estimate pi as being 3.14, but we don't have to do that. this is an exact number sitting right here. We can leave it just like that. 4 minus this symbol pi. And we're done. That's the answer.